During the Second World War, when rain turned battlefields into rivers and dugouts into swamps, most soldiers couldn't count on staying dry. Canvas tarps tore, tent seams split, water pooled and froze around their boots. Yet, scattered across Europe, certain frontline units stayed dry, even under weeks of bombardment. Their secret wasn't better fabric, it was a method. Military engineers learned to seal and insulate dugouts using nothing but earth, ash, and waxed cloth. The result was a natural waterproofing system that outperformed anything the factories could make. It was cheap, it was field-tested, and most importantly, it worked when everything else failed. When tarps failed, soldiers turned to the ground itself. Tarps were never built for the kind of punishment the war delivered. On the Western Front, the issue wasn't just rain, it was relentless soaking mud that ate through canvas in days. Once water breached the fibres, cold crept in instantly. Soldiers realized they needed something that behaved more like skin than fabric, something that shed water and retained warmth at the same time. That idea sparked a quiet engineering revolution. Frontline sappers and carpenters started combining old-world building logic with military necessity, studying how cob houses, trench ovens, and earthen walls handled moisture without rotting. From that blend of observation and desperation emerged the sealed earth roof method, a layered self-reinforcing system that turned mud into armour. The sealed earth method was part science, part survival instinct. It began with a simple frame of flexible poles, often willow or hazel, bent into a shallow dome or lean-to arch. Over that structure, soldiers packed a thin layer of wet clay mixed with fine wood ash or charcoal dust. The ash acted as both a drying agent and filler, tightening the clay as it cured and making it resistant to fire. Once the clay stiffened, they draped it with any available cloth. Old tent canvas, uniforms stitched together, even bedding, and brushed it with melted wax, linseed oil, or animal fat. As it cooled, that coating transformed the fabric into a water-repellent membrane. A final layer of clay mixed with straw or soil went on top to shield it from shrapnel, sun, and heat. What they built was a living roof. Clay to absorb impact, wax cloth to block moisture, and earth to insulate. Water rolled off instead of seeping through, while the trapped air between layers kept the interior stable. Even under artillery shock, the structure held firm. Where regular tarps sagged into puddles, these shelters stayed dry for days. The genius of this system lay in how it managed moisture. Modern tarps repel water through surface tension, but once stretched or punctured, they fail instantly. The sealed earth method worked through absorption and redirection. The outer layers soaked up and dispersed rainwater outward, while the waxed middle layer blocked internal seepage. The ash and charcoal mixed into the clay also played a hidden role, neutralizing acidic rain and preventing bacterial growth, a vital factor when men lived underground for weeks. British and German field tests after the war proved that this combination could withstand up to 4 days of continuous rain without a single drip. When paired with proper trench drainage and slope grading, these shelters remained dry even in flood zones. This simple design saved more than just comfort. It saved equipment, ammunition, and maps. In conditions where a wet rifle could jam and a soaked radio could fail, keeping things dry was a matter of survival. Entire command posts, kitchens and first aid stations were protected using the same principle. Many soldiers later recalled that their best night's sleep came not from canvas tents, but from dugouts sealed with this method, quiet, dry and almost warm compared to the open air. Today, this old trick remains one of the smartest ways to build a natural, waterproof shelter. You don't need a battlefield to see its value. Off-grid builders, homesteaders and long-term survivalists have rediscovered the same principles for earth lodges and root cellars. To recreate it, start with a strong arch or A-frame of greenwood branches. Mix 4 parts clay to 1 part wood ash and spread it evenly over the frame, letting it stiffen slightly. Next, coat a layer of fabric, old canvas, cotton sheets or burlap, with melted beeswax, candle wax, or even animal fat until it's pliable but sealed. Lay that over the clay, press it down gently and finish with another inch of clay mixed with straw. Once dry, you'll have a breathable, waterproof shell that handles rain and wind naturally, without any plastic or synthetic coating. This design also scales easily. Builders have used it to line underground food stores, reinforce hillside bunkers, and even create low-tech, energy-efficient cabins. The same science applies everywhere. Direct moisture away, trap warmth within, and let the structure itself regulate temperature like skin. It's the foundation of what modern architects call thermal mass sheltering. Using the Earth's natural properties for insulation, airflow, and temperature stability. Those wartime engineers didn't have the terminology, but they understood the principle perfectly. When it rained, the clay layers swelled to seal cracks. When it dried, the surface hardened and reflected heat. The system adapted to its environment, just as the men inside had to. Even today, surviving Second World War bunkers across Europe still show traces of these waterproof clay layers. Decades later, they remain intact, long after the fabric beneath has rotted away. The earth itself preserved the proof of what soldiers once built out of necessity. This technique wasn't about luxury or comfort. It was about making the environment work with them rather than against them. That mindset, resourceful, practical, and grounded in real-world understanding, is what makes this method timeless. It's a lesson in resilience and problem-solving under pressure. The brilliance of the sealed earth roof method lies not in complexity, but in balance. It turned raw mud into architecture, fat and wax into sealant, and waste ash into protection. A complete ecosystem built from the simplest materials on hand. It's a reminder that real engineering doesn't always come from blueprints or factories. Sometimes it's forged in the mud of history, where survival demanded invention. If you value the forgotten science that kept soldiers alive beneath the storms of war, subscribe to Relic Logic and share this with someone who respects ingenuity born from necessity. The greatest lessons of the past aren't found in textbooks. They're buried in the trenches, waiting to be rediscovered.